All right, name a pair of alternate interior angles. So the first thing I'm going to say is the interior is the one between the two lines. So you have to recognize that this is... Why is that still up there? Weird. Yeah, that is our transversal. And your interior is the stuff that's between the two lines. So that's your interior. So when I'm giving an answer that has interior, I better use 3, 2, or 4, because that's what interior means. Can someone tell me which ones is on the interior and are an alternate interior pair? Looking for an alternate interior pair. I got 3 answers. 4. Sizer. 4 and 3. Do we agree?
Yeah, I agree.
Okay, then I'll write it down. As long as Songhao agrees, then we're good. All right, name a pair of corresponding angles. So everyone except for one person should know this, and maybe that person already corrected it. Angle 3 and angle 5. Perfect. Remember, corresponding is, so if you look at that 3, it's in the top right of all 4 of those angles. So you look at the top right of the other one, which would be 5. All right, we just have one more. We have one more. Labib really wants to answer it, but I'm not going to let him. No, I'm kidding. Same side interior, yeah.
Angle 2 and angle 4.
Angle 2 and angle 4. Guys, in this chapter, you have to be able to recognize these. You have to be able to quickly do it because you'll look down below. We're going to start doing proofs. So you got to quickly be able to recognize how you get from one angle to another angle with congruencies. All right, that's what's going to be important, recognizing what the angles are and what that means when they're parallel. So you got to start. If you're someone that's taken a long time, you need to keep practicing alternate interior, same side interior, and bring in back vertical angles. All right, those angles will happen here. Because if you look at 4 and 5, they're vertical angles, so they'll be the same size. They'll be congruent. You have to be able to pick those up pretty quick. All right, we're just going to run through some postulates and theorems that are going to be important for just this little section that we're talking about right now. We're going to do 2 more tomorrow. All right? What does that mean to you? Hey, locate your pink sheet. I would strongly encourage you find your pink sheet. Maybe put some marks on it. Maybe be like, hey, these are the ones that deal with transversals. So when you're taking the test, you can go right to the transversal ones. Because if you look at each of these, transversal, transversal, transversal. Do whatever you need to quickly do it. Or if you're good on these, don't write anything down. All right, I'm not forcing you. Those are your pink sheets. You can use them on your test. So you can just take the notes like we're doing here, or you can take them in your pink sheet. I don't care. So the first thing we're going to talk about is the corresponding angle postulate. The corresponding angular postulate says, if 2 parallel lines are cut by a transversal, then the corresponding angles are congruent. Here is the important part of this. It is the if part. So look at that drawing. This says if A is parallel to B. Just look at this drawing. Do we know for a fact they're parallel? No, they aren't.
What?
They aren't parallel until I specifically say they are parallel, or I put little arrows on it saying, yep, those 2 things are parallel. No matter how closely something looks to 90 degrees or parallel, it isn't that until I specifically say it. If you are assuming something's parallel, you're making a mistake. It will specifically say, hey, these 2 things are parallel, or I'll have those 2 arrows on it. Be careful, because each of these are based upon them being parallel. So you first have to ask yourself, do I even have parallel lines to start off with? All right, so this says if they are parallel. Oh, let's get out of red. If they are parallel, then angle 1 and angle 2, I'll just put the congruency symbol. Angle 1 is congruent to angle 2. That is if they're parallel. Then corresponding angles. So these 2 angles would be congruent. These 2 angles would be congruent. These 2 angles would be congruent. And these 2 angles would be congruent. Does that make sense that each one has a pair? Each one of these 4 things has a pair down there. So if I was looking at, let's call this 4, I would know that'd be congruent with 5. All right, our next one is if parallel lines are cut by a transversal, then alternate interior angles are congruent. Once again, we have a giant if here. So if A is parallel to B, then angle 1 is congruent to angle 2. Or we could be on the flip side. Right? This could be 3 and 4 would be congruent if we had 3 and 4 out there. Labib, do we know for a fact those are parallel? No. You will either know for a fact or you're just going to assume they're not. Either I tell you for sure that they're parallel or you can't assume they are. All right, last one. It says Theorem 7. If a parallel line are cut by a transversal, then the same side interior angles are supplementary. Can someone tell me what supplementary means? They all seem to get it on the test. Yeah. They add up to 180. Perfect. But once again, this is on the preface that if, and I think I have different letters, K and N. So K is parallel to N. Then angle 1 and angle 4 are supplementary. Those are going to be your major postulates and theorems we're going to use for this whole assignment here. And tomorrow we're just going to add 2 more onto them, and those will be your major ones that you use on stuff tomorrow. The other ones you got to think about are like vertical angles, because we're still dealing with angles. And maybe like the transitive property, maybe subtraction property of equality, something like that. That being said, our proofs on the test were, for the most part, really, really strong. For the most part, they were really, really strong. All right, we're going to start our first proof. Now, what I'm going to bring up here is, see how it says theorem? This is the only thing you can't use in your proof because you're proving it true. So once again, if I put theorem up here and you read it, that's the only theorem or postulate you can't use in your proof. Otherwise, you can use anything else that we've learned. All right, that's your only stipulation is you can't use this. And I'm going to go ahead and gain my point by just writing down my given. Because this should be a super easy point. Make sure you number them. Some of you aren't numbering them. Make sure you number your steps so I can see across which step goes with what. Yeah. What about it? Yeah, it's parallel. Yeah. So A is parallel to B. Oh, you're just asking, you're confirming that it's parallel?
No, I was just asking.
Oh, okay. And I think you have a drawing. I think you have a drawing in yours. Mine, for some reason, didn't show up on my thing, so I'm going to go ahead and draw it. All right, where this is 1, 4, 2. This is A, this is B. Since A and B are parallel, a lot of times I'll actually put my arrows up in my drawing. Because guess what? We're going to get to more complicated stuff where some lines are parallel and some aren't. So it's always nice just to have it in the drawing. So we have these two things are parallel. Yeah.
I know the next step.
Cool. What's the next step?
Well, angle 4 plus angle 2 equals 180 degrees because of theorem 1.
Okay, angle 4 plus angle 2 equals 180 degrees. Step 2 is because of theorem 1. Let's see if that's right. Let's see if that makes sense in the flow of this. So I want to say angle 1 and angle 4 are supplementary. To be supplementary, 2 angles add together to equal 180 degrees. So the first thing you want to do is have 2 equals that do equal. 2 angles that do equal 180 degrees. And guess what? We have a quick linear pair right here, 4 and 2. 4 plus 2 equals 180 degrees. That is theorem 1. It says a linear pair equals 180 degrees. Probably a good start, right? Because now we have 180 degrees up there. Well, we want angle 1 plus angle 4 equal 180. So I want to eventually get rid of this angle 2 and replace it with angle 1. But that means they both have to be congruent to each other, right? Right?
You could say that angle 1 is congruent to angle 2 by theorem 6.
Angle 2 is congruent to angle 4. Yeah. Angle 1. I zoomed a little too far in. Now you could put, what is it, theorem 6? Is that the number of it? What I usually do is I name the angles. These are alternate interior, because a lot of times you don't want to shuffle through that pink sheet because you know it's there. We know alternate interior angles are congruent. It should be something that is just going to be ingrained in us. So rather than having to look at my sheet and see what theorem it is, I'm just going to say alternate interior angles theorem. Or you can actually just put alternate interior angles. Is it okay to write theorem 6? Absolutely. I just like to be able to name things. So I'm like, oh, I know for a fact alternate interior angles are congruent. I'm just going to put alternate interior angles on this side. All right, so what we did, we added 2 angles to equal 180. We said I need to replace 2 with 1. And the only way I can do that is if 1 and 2 are equal. And we set them equal to each other. Now what we can do is I can substitute angle 1 in for angle 2. So our next step is angle 4 plus angle 1 equals 180 degrees. And that is substitution. And we do need one extra step. Libby? We can go right to our finished answer. Remember, we were just trying to show that 1 and 4 are supplementary. We showed they're supplementary. Now we've got to say that they are supplementary. So showing is different. So this is the definition of supplementary, but I need to say that in the next step. So I need to say that angle 4 and angle 1 are supplementary. And that's just the definition of what supplementary means. Labib.
Why did you add another step? Why couldn't you just do 4 and end it there?
Oh, on step 4?
Yeah.
Because you should, for the reader, say, because do you see how this is supplementary? You should tell the reader that, hey, this plus this equals 180 means they're supplementary. So you should end with the same statement they started with. I get that for us, because we've done this so much, that we just know that means supplementary, but you need to explain it. Get yourself out there saying, I know what this means is supplementary. Questions about this proof at all? How was it? Good. I sometimes find these easier than the ones that you have to add a whole bunch of stuff in. All right, our next one says, if 2 parallel lines are cut by a transversal, then alternate interior angles are congruent. So we cannot use our alternate interior theorem. We can use anything else that we want. Let's just do the given so I can get a point. So if you're running out of time and there's a proof, just write your givens down real quick. This can give you some point. All right, we have angle 1 is congruent to angle 2. So I need to show that angle 1 is congruent to angle 2. We already know this, so hopefully we can do it because we do have a theorem that supports it, but we can't use that theorem. So I need to somehow get from 1 to 2. Sizer.
Angle 1 is equal to angle 3.
Yeah. You know what? That's just a good thing to recognize. Even if you don't think it's going to help in the proof, look for vertical angles. Look for things that are congruent and write it down. So we can say that angle 1 is congruent to angle 3. And it's because they're vertical angles, right? Yeah, you could put theorem 4 or just put vert angles. I like this because I don't have to look at the pink sheet. I know that vertical angles are congruent. I don't need to look at it. Just write vertical angles. All right, so right now we have 1 going to 3. What should I do next? John, did you have it and lost it? Or do you want to? You lost it? All right, yeah.
Angle 3 is going to be similar to angle 2 because the corresponding opposite.
Yeah. So we got 1 to 3. Let's go to 3 to 2. And that is our corresponding angle. So I have 1 to 3, 3 to 2. I bet there's a better way to do it. Because we're going to go right to the answer here, right? Yeah. Substitution is 100%. I would accept that answer. I think a better explanation would be the transitive property. But I'd fully accept substitution. The reason why I'd pick transitive is because we go from 1 to 3 and then 3 to 2, so we can link up the two ends. But I don't want to make you confused. Substitution would have been 100% fine. I would accept that. Because it really is substitution. You kind of use substitution to prove the transitive property. Bless you. Yeesh. You're done now, right? Okay. What I want you to do right now, I want you to look at the next proof. And I want you just to think through it. At least write down the given. Think through it. And if you think you know what you're doing, start it. Start the proof. Start writing something down. You have pencils. You can erase them. If you get done before I give the time up, then look at the next one and see if you can do that one. So just try your best on these. You should kind of have a second to think about it. I do want to preface this. Do not just erase yours. There are several ways to do this one. So we're going to go down one path, and I'll kind of talk about the other paths and just see if you picked a different path and it's still correct. You know what I'm really good at? Writing the given. That's what I'll do it for you guys. It's just one of my talents. I was born with it. You can't learn it. It's just a talent you're born with. And I was born with it. All right. Who wants to take a guess at what my step 2 is? And just a quick reminder, there are... Say that one more time. Angle 3. Oh, 2. The corresponding angles. Do you all agree that's true?
Yes.
Yeah. Sangha, you were so disappointed I didn't call you last time. What should we do next?
So you have to do, remember, angle 2 equals to angle 5, and angle 4 congruent to angle 7.
We only need one of those.
Okay.
We only need one. And think about it. So we need to get to angle 7, right?
So I will just use angle 4 equals angle 7.
Perfect.
Because theorem 4 or vertical.
Yeah, perfect. So we're going to say angle 4 is congruent to angle 7 because they are vertical angles. Sangha said 2 things. He said you could list these 2 and that one. Do you think you lose points for listing too much stuff?
No.
No, it can confuse you. But you could list both of those facts in there. It's fine. It's facts. All right, so we have 2 to 4, 4 to 7. Are we okay going to 2 to 7 then? Yeah. So we have our final answer is angle 2 goes to angle 7, and it's our transitive property. Multiple ways to do this one, right? Let me just go through. Yeah.
So I feel I'm getting confused between substitution and the transitive property.
Gotcha.
Can you just explain that?
Yeah. So substitution, you're typically using substitution if you are straight up have like kind of an equation and you're replacing something in. All right, you see here that I'm replacing this. I'm actually subbing it in. The transitive property, I'm thinking I'm connecting multiple things. I'm saying 2 to 4, then 4 to 7. So these 2 things end. Would you be okay putting substitution here? Yeah. But it's kind of a train. It's kind of like 2 to 4, 4 to 7. That is our transitive property. Substitution is usually use substitution when there's some kind of equation. See how I have 2 things equal and I'm replacing one element of it? That's usually when substitution happens.
Okay.
Transitive, generally, if you just have 2 things on either side that you just... Is that a little clear?
Yeah.
All right.
So would you take that in a test?
I would take substitution on this one. Yes.
Okay.
Because you really are using substitution, right? Because you are replacing 7 with 4. Yeah, I would absolutely accept that. All right, so another way you could have did this, you could have said 2 is the vertical angle of 5, and 5 is corresponding to 7. I've seen people take long routes. They went like 2 to 5 because they're vertical angles. Then they went 5 to 4 because they're alternate interior. And then they did 4 to 7 because they're vertical angles. Do you think I take points off because it's a longer proof?
No.
No. You just got to create that chain of events that gets you from the beginning to the end. I don't care how you do it. I don't care what information you have as long as it's all correct and you have it supported on the other side. All right, let's do one more together. So I have step 1. K is parallel to L. And that is my given. Supplementary means they add to 180, right? So I need to effectively use 1 or 7 to create something that's supplementary to something else. Davion?
1 and 5 or something.
We could do 1 and 5 are supplementary. Perfect. So instead of saying they're supplementary, I'm just going to go angle 1 plus angle 5 equals 180 degrees. And that is going to be theorem 1. Yeah, what's up?
Can you put that angle 1 is supplementary to angle 5, would that also be allowed? And then you just substitute
5 and 4. Yeah, it's a little cleaner with the equation, but I understand what you're saying.
Is that okay?
Yep. All right, so we have that. Our step 3 is, man, if only I could replace this 5 with 7. And the only way we could do that is if they're congruent to each other. Is there any way to show that they're congruent to each other? Yeah,
Corresponding angles.
they're corresponding angles. You didn't cheat. You did cheat? Okay.
No.
All right, so we could say angle 5 is congruent to angle 7. And that is because they're corresponding angles. Well, now we could take that 7 and substitute it in for that angle 5. And then we can say step 4 is angle 1 plus angle 7 equals 180 degrees. So our step 4 was substitution. And our step 5 is actually our answer. Angle 1 and 7 are supplementary. And that's just the definition of supplementary. Yeah.
Step 4 would be the transitive property.
No. I'll talk about that in a second. So the transitive property has to be kind of a bunch of things connected together. 2 goes to 4, 4 goes to 7, so the beginning is the same as the end. Note here I have this whole thing equals 180. And then I have this equals, it's not a chain of things, I'm actually just replacing one element. I'm replacing one element. It's not a chain of events, it's just one element being swapped out. Davion, sorry.
What if I use what if I say in step 2 that 1 and 5 are supplementary, and then I say like the same thing 5 and 7,
And then you just replace.
then I just replace it.
Yeah, that's okay.
Same stuff.
This is a little cleaner because it's a little weird substituting something into a statement. It's a little cleaner to do this, but I would accept that on a test for full points. Yep. The reason why I picked this method is because it's kind of a common flow. If you remember the ones we did before where we came up with the statement and we replaced one thing, but yours is 100% fine, it'll work. I'm really looking for, did you use corresponding angles? Did you replace something? I'm looking for those big swaths. All right, any other questions? Megan, do you have a question or are you thinking?
I'm thinking.
Oh, okay. All right, well, she's thinking, just in case she has a question, questions on the homework. We did have homework. Megan, did you still have a question or did you sort it out? Okay. Picture of it. So the question was number 17. You put what? Okay, let's check it out. Maybe I made a mistake. I've done it once in my life. All right, so we have GCH. So we have GCH. So we create that angle. Then we're going to have GLJ. GLJ. Now if I extend each one of these to be a full line, we can see where our two lines are, and then let's go ahead and circle. Oh, I'm going to go ahead and note each one of them. So we have GCH would be right here, and then we'd have GLJ, which should be right there. What should that answer have been? It should be corresponding. You're 100% right.
Yeah, I got right.
Yeah, good job.
Oh, I'm right.
You'll just get a point for that because that was a mistake in the answer guide, so you get a point for finding the mistake. Remind me when I walk around, because I give you the point on the homework. Unless you don't want it.
Yeah.
Oh, you don't want it? Okay.
No, I do.
Nope, I can't go back now. You said no. All right. Other questions? Yeah. 27. Did I do that one wrong too? Did I do that one wrong too? Okay. So 27 says name 4 planes parallel to FL. So let me take a picture of that guy. So we're looking at this picture here. Ooh, that might be a little fuzzy. Let's see. That'll be good enough. All right, so I'm looking for 4 planes parallel to FL. So let's highlight FL. FL is this guy back here. All right, so parallel are planes that don't touch it, basically. They're planes that don't touch it. So the top and the bottom are out because they're touching it like throughout this whole thing. The bottom's touching it right there. So those are out. See this A, F, B, G? Let me highlight it.
Oh, okay, yeah. But how do you know it's not the other side plane? Like F-E-K-L.
F-E-K-L?
Yeah, because that's what I kept doing.
Oh, you kept picking this one?
Yeah, so then I got the wrong answer.
Well, here's the thing. Do you see how it's touching right here? Remember, this plane goes forever. So this plane actually encompasses this entire line. So it can't be parallel with it because it's touching at a whole bunch of places. To be parallel, it can never touch. In fact, it's already touching without even extending it. So they can't be parallel. So the ones that are going to be parallel are like this E, D, J, K. The one here, the one here, and the one angled here. Does that make more sense? Okay, good. You sure? Okay. Other questions? Get clarification now, not on the test.
I was asked number 22, the second drawing.
Okay.
I'm confusion.
How to draw it?
Yeah.
Okay, so it's just describing an easy way to draw it.
I mean, I didn't know what they're asking me, what to draw.
I just asked you to draw, follow the steps. To draw your own.
The second one. The what? Step 2.
Right here. You just draw it. You just draw the
I
shape.
draw over here.
You were supposed to draw it over here.
Oh, really? I just draw the right line here.
It said step 1, draw a 6-sided top and a 6-sided bottom. Step 2, draw. So you're supposed to draw the whole thing. All right, other questions? Yeah, Emma.
So for number 28,
Yeah.
how are there only 4?
So there has to be 4.
But I got 8.
No, like count.
I was counting the pairs. I was counting the pairs, so I wasn't counting each one that was parallel to the other side. So like,
Okay.
guys, can you let me explain this? So like the top and bottom is one pair. They're parallel, one never intersect. This front one and that back one is pair number 2. The one that's angled this way and the same one on the opposite side. Oh, okay.
Parallel
Yep.
lines.
Entire
I did
planes.
lines too. I got like 21.
I got 18.
Oh, so you guys all did lines?
Yeah.
Okay. It was the plane.
Also,
Yeah.
so it says name 5 lines that appear to be parallel. So I used the line sign, but in the answer key, they're just segments.
Oh, it doesn't matter. You're fine.
They're both fine.
Yeah. Because segments are given in the drawing, but we also know they're lines as well. Other questions on homework? Some great questions. Glad we got some of that flushed out, so it's not like, meh, I don't want to ask. I'll wait till I study.